So I'm going to do two things. I'm going to talk a bit about environment very briefly, because I think the industry's responsibility to the environment is quite broad, and water's only one piece of that, and I think it's important just to touch on that. And then I'm going to talk about what the industry's doing with water-related issues, and then I'm going to go into some detail about a whole range of things on that. So, environment. So UKOOG, you heard from Ken this morning, no doubt, what UKOOG is about, so I won't go any of that in detail, but really, when we look at the environment, as an industry, we have to work with a large amount of environmental regulation. There's something like 17 EU directives, there's 8 or 9 permits. Most of those actually are perhaps related to water, groundwater. And the industry as a whole recognised early on it had to engage on the environment. Now, we've had an existing onshore industry you've heard about this morning for a long time. But when you bring shale into the equation, it brings in a lot of other questions about environmental issues. So we're committed to doing things like an early stage environmental risk assessment that DEC put forward, and in doing environmental impact assessments for every site that would use high volume hydraulic fracturing. And things like fracture fluids, we've agreed complete public disclosure of those. And also the amount of water we use, and then how we manage and deal with that water, and the amount of water we have at the end that we treat as waste. So really we're talking about disclosing an awful lot of information here, which is about the broader environment. And then we do, as an organisation, drive best practice. So we have things like our well guidelines, which were published in 2013, and we recently published guidelines on baseline monitoring, which I'll go into in some detail later. So really, as an industry, we recognise we have to interact with the environment, be it water or whatever. So we saw a few of these pictures earlier from Mr. Blaemeyers. We saw the golf course and we saw a bit about Poole Harbour. But I think for us, this captures the message. We're used to working in environmentally sensitive areas, be it water as an issue, be it ecology, be it whatever the receptor issue might be. We're very used to working in those kind of environments. So, there's a key message there in that if we are going to establish our social licence to operate for shale, then actually that's a message we need to grow and expand upon. And water is kind of in the middle of that issue. So, down the bottom there we have this hunting for these newts, as John talked about. But actually it's about restoring the environment to the condition it was in. We're an industry that interacts with the environment for a period and then perhaps moves away and leaves it in hopefully its original condition as far as possible. So, and the way we manage water has to be part of that, has to be a key part of that. So, water in the onshore industry. So I'm going to talk about what the industry is currently doing and where we're currently heading. And it's going to cover a number of things. It's going to cover regulation. So this is what I used to call the shale gas bagel, which if you had that for lunch here, it'd probably give you terrible indigestion. But really, it's a cross-section through the regulatory arrangements that we have in the UK. So we have a number of regulators in the middle that regulate a whole range of things in that kind of lime green bit. And water, as an issue, kind of appears in all of those blue bits. So really, all of the regulators have to consider water in some fashion, not just the environmental regulator. So we have things like the environmental risk assessment, which DEC requires. And water's a key part, to be considered in that. So, water is perhaps the only receptor that actually is considered across all of the regulators, which does make it slightly interesting. And then if you think about the supply and demand chain, and if I can get is there a light thing somewhere that works, projects?
Yeah, I think.
Okay, I won't do it in case it makes it skip. So basically, we have a supply-demand chain map here. And really, I've identified kind of where water fits in with that black dotted line. So actually, water is kind of a key resource to enable the industry to actually happen. Now, that's whether you're doing high-volume hydraulic fracturing or not. And I think that's a really important message. So we kind of have a responsibility to manage water, perhaps in a different way to most of the other things we deal with as an industry. And actually that brings a conundrum in for us because, we do need to use water, and it has to come from somewhere, and then we need to manage the products at the end. So we need the infrastructure and the technology and everything else that supports that happening. And this, I think, is where engineering minds come in. There's a conundrum for us to solve. There's lots of technology out there, but we don't know which bits of that technology we should be looking at as an industry. So, I want to talk a bit about some drivers that drive us to do a number of things, and this is really about establishing environmental baselines. And some of this you'll have heard. So we know there's a social license to operate that we have to achieve, and we have to build that. And we can build that by being transparent. And actually, by collecting data on environmental baselines, it helps us with our regulatory, permitting, kind of compliance processes. And it helps lay some foundations, really, that will set the industry in a good place for the future. There will be, no doubt, environmental issues on a site, whether it be a minor spill at the surface or whatever. And actually, if we have robust information about the environment and the water environment right at the word go, it means that we know exactly where we are and where we started from. Also enables the reinstatement of sites, which is fundamental. As I said, we're a kind of transient operation, and at the end of the day, we will hopefully go away leaving that environment in the condition it was in. But without that record, we can't prove that that's the state we left it in. And then finally, managing politics, I guess, is a key thing. As you've seen, there's been an infrastructure bill and now an act. And managing the politics around these issues is very key. So, environmental baselines then, of which water is a key part. And then there's a flow diagram in a minute to show you some of this. So we, a few months ago, set out on a task to develop some guidelines that were risk-based, that looked at science, that looked at this conceptualised site model, which is best practice across many industries, really to pull together thinking about the key receptors that our industry interacts with. So we have groundwater. We drill through groundwater. We have to isolate ourselves from that groundwater. We have to protect that groundwater. There are surface water issues. We have to deal with the surface water that falls on a regular basis, especially in the northwest. And then there's a whole range of other receptors: soil, air, water, normally occurring radioactive material. All these kinds of things that have to be established right from the word go, or at least an understanding of them. So anyway, we published these guidelines in January. And we had them peer-reviewed or scientifically reviewed by a panel from the Society of Environment, because actually we wanted to be challenged on the techniques and the kind of approaches we wanted to adopt as an industry. So really, if you look at water, we have to look at water right from the beginning. So right from, before you go to that site, what is the current condition of water? And then when we bring more water to the site and manage that operation, then obviously we have something to compare that kind of water environment against. Now here we go. So this is something about the monitoring process. So if you think that we establish our baseline down at the bottom end here, down at the far end, we would establish that for water-related receptors, so surface water, and then obviously the groundwater side. And this is then a journey, and there's a journey through us as an industry having permits granted by the environmental regulator, which we then have to comply with. Now hopefully we don't have any issues, but if those issues arise, then we have to obviously deal with whatever that may be. And there'll be various things happening. So we mobilise on a site, we would then drill, and we would then hydraulically fracture, and then we would decommission a well. So we're managing water and the environment throughout that entire process. And when we get to the end and we actually want to decommission that well, then there's the conundrum of, well, actually, what do you need to monitor post that decommissioning? And actually, that's a challenge. And actually, if you think about it, you probably wouldn't monitor surface water because you're not interacting with that anymore. But you have a well in the ground, and actually possibly needing to monitor groundwater for a period of time may be sensible. And of course, the environmental regulator will have granted you permits, and they'll be expecting you to relinquish those permits at some point. So actually what we're saying here is that, not just for water, but for all of these receptors, there's a journey. And that journey could be perhaps 30 years, who knows? We may have these sites up and running for that duration. So, what we've been doing is some work on integrated water management, because we recognise that we can understand the baseline, but then when we interact with it, there's a whole lot of things going on. So what we've done, we've set up an initiative with the steering board and a number of organisations, and there's an opportunity here for IMechE as an institution to get directly involved with this. Not quite sure how we do that. You can come to us and suggest it. But we've decided we needed to look at 4 key areas and the interaction between them. So we're looking at the kind of supply delivery of water. Okay, so there's lots of myths out there about the volumes we use, and there's a slide later that kind of puts that in comparison. But then best practice management of that water on site. And then, of course, actually, we are an oil and gas industry that wants to maximise the opportunity that those oil and gas bearing rocks bring. So actually, there's a big piece here about the operational use and reuse of water. Because if through high volume hydraulic fracturing, water is the resource we need in order to get that hydrocarbon, then clearly we have a responsibility for managing it and getting the best out of it as well. And then clearly at the other end of the day, at the end of the scale, we have this waste to manage and to get rid of. We have European regulation, we have mining waste directives, we have a whole range of things we have to comply with. But if we can minimise the waste stream and maximise the kind of opportunities through the reuse, then actually we reduce the truck movements we have. So there's a whole range of interesting sort of parallelism here for, across the board. And then we have a lot of kind of cross-cutting issues, such as analysis suites. What do you test for in existing groundwater now that may use in 30 years' time, and how do you deal with that? So there's a whole range of things. So we set this group up to try and take this forward. So back in December, we had a meeting to establish a steering group of scientists, academics, industry experts and others, people from the water industry. You saw Water UK, British Water, Chartered Institute of Water and Environmental Management, to bring them together to actually look at this collectively. And we recognise that we have an existing regulatory system that's very robust and lots of permitting arrangements that are very robust. But actually, maybe if we look at water in a different way, maybe there are different ways of doing this in the future, so we challenge ourselves with that. And we see this as a long-term opportunity to work with regulators to help identify some of the best available techniques. The environmental regulators at the moment are doing some work on that. And there'll be many things that are used internationally that could be used in the UK. But at the minute, we don't have an industry in which they can be tested, but we think that should be done. So we will wrestle with these kinds of conundrums. So what are the next steps? So at the minute, we're shaping up a programme. And we'd like this programme to have as much input from experts like yourselves, really, where we can. So this first quarter of 2015 is about that programme and about identifying those priorities. And then what we want to do as we move into the spring and summer really is to look for those quick wins. So what are the analysis suites? What are the techniques and technologies out there that enable us to reduce the amount of water we use? And how useful are they in a UK regulatory context? Can we get them over here? So, this is where you can help us. So some of the challenges and benefits then, just really to sum up, and some of the opportunities. Look, we know as an industry that transparency is absolutely critical here. So that's from baselines through to how we interact with the environment, through to when we close out a well. And at the heart of that is this environmental data and being able to provide that transparently to the public and to the regulators. But we do have some existing institutional frameworks which may not be hugely helpful. So things like the mining waste BREF, the mining waste directive, was designed for solid waste, not really for liquids. So actually we do have some kind of regulatory arrangements that make life slightly more difficult, and I think we need to challenge some of those. And really also maximising the opportunity of shale, looking for new technologies, looking for technologies that use less water, and actually maximising that opportunity that they bring. I mentioned the bat, bringing bat across from elsewhere, scaling that up, or having a model that works. What we clearly won't have in the UK is a kind of industrial process that moves across the landscape that you see in some states of the US. What we will have are these fixed pad sites. You heard John Blamires mention them. And actually, that in itself brings an opportunity, but a challenge. It means that some of this mobile technology they use in the US, US, probably won't work here, but actually we can have more fixed sites because our sites will be there for longer. And then finally, independent monitoring and bringing some of that into the debate. Back in the autumn statement, the government announced that BGS would do some independent work, some independent monitoring of the environment, of water, background methane, all those kinds of things. And I think that's key here. There is an element of independence, and I think institutions like the Institute of Mechanical Engineering can help bring that independence actually to some of the discussion, the decision making. So that's it.
Okay, perfect.